Hey everybody! Welcome to a beginner-friendly introduction to geometry nodes in Blender. Geometry nodes modifiers are an incredibly powerful tool for creating procedural models and effects. This video will have 3 parts. In the first video, we'll look at how to set up a geometry nodes modifier, explain nodes and connections, and look at mesh objects and transforming them. And we'll take a look at attributes and fields. In the second video, we'll cover instancing, points, and curves, and how to add materials to your geometry node's output. Then in the third video, we'll wrap up with a simple landscape project done in geometry nodes. First, let's talk a little bit more about geometry nodes. At their core, they are a modifier, but they're a really powerful modifier, as you'll soon see. Let's take a look at an example before we dive into creating one on our own. I usually open a geometry nodes editor in the default layout workspace, but for now, we will go into the geometry nodes dedicated workspace. In this workspace, you'll see the 3D viewport here, and the geometry nodes editor here, as well as the spreadsheet, which contains a lot of useful information you may need as you're setting up various parts of your nodes. For example, we can see that our cube has 8 vertices, 12 edges, and 6 faces. We can also see the position for each of the vertices here. We'll take our default cube and then we'll add a geometry nodes modifier here and set it to a modifier I have already created called extrude. Each of these boxes is a node and the lines between them are connectors. The dots where the connectors attach are called sockets. Each socket has a data type, and you must attach the type of value it is expecting. For example, we can see that we have a geometry socket plugging into a mesh socket here. You can see that both sockets are colored green, and we can plug a few different types of input here, but they must be a geometry object. The group input here represents the mesh that we applied the modifier to, in this case our default cube. For the input, we aren't limited to using the mesh we applied the modifier to, however. For example, let's bring up the Add menu by using Shift A, and we'll use Mesh, Primitives, Cylinder. By the way, we can also find any node we're looking for by typing after hitting Shift A, and you'll see me do that often throughout the video. Now we'll use the mesh from our cylinder to connect with the mesh in the extrude mesh. We can see that our cube has been replaced, and the cylinder we added now has its edges extruded. Let's adjust the amount of the extrusion. We can see that the amount of the extrusion adjusts while the underlying mesh remains the same. The output we see here is the result of all of our operations or nodes, and this output replaces the underlying mesh we are modifying. Let's disable our geometry nodes modifier and see that our default cube is still intact. If we decided to apply our modifier, all of the changes would become permanent. Not only can we replace our mesh with a different primitive, but we can also replace it with a mesh we have modeled. Let's bring in this shape object I have in the outliner. We can just drag and drop it into our editor. Now we can plug the geometry from our mesh into our extrude mesh node, and we can see that my shape is now displayed with its edges extruded. And our cube still exists if we turn off the modifier again. So let's make our modified cube invisible and add a UV sphere. Now we'll add our geometry nodes modifier to it. And we can see that our sphere becomes our shape object. Let's go back to using the input geometry instead. And now we have our sphere with extruded edges. Now let's dig in and create some geometry nodes of our own. Let's make our current objects invisible and add a plane. We have a couple of different ways we can start our modifier. We can either click the New button here at the top of our Geometry Nodes editor, or we can add a modifier, choose Geometry Nodes, and then click the New button here on the modifier. We can see that we have both an input and an output node. As we discussed, the input refers to our plane, and the output refers to how the object looks at the end of our modifier. Currently, we are only outputting the same object we are inputting, and we're not modifying that object at all along the way. Let's disconnect the input from the output using Control and the left mouse button, and we see that our plane disappears completely. The object still exists, and we can see that if we disable our modifier, but with the modifier on, nothing is going to our output, so we won't see any object in the viewport or render. We can reconnect this and add some nodes to transform our mesh. First, we'll grab a subdivide mesh node. Let's bump the level up to 4. And if we turn on wireframe on our overlay, we can see those subdivisions now in our mesh. Now let's delete some of our geometry. We'll add a delete geometry node and set the domain to face. And then for our selection, we'll add a random value node to randomize the selection of faces we will delete. This can give us a very natural looking deletion. Let's also add an extrude mesh node to add some depth to our geometry. We can adjust the height by sliding the value for the offset. We can also change this to edges or vertices, depending on what we want to do with our mesh. So let's go ahead and change our input mesh. We'll try a few different primitives. Let's first add a cube. We'll also try adding a UV sphere. We can really add any of the mesh primitives available. They are all available in the Add menu, which is Shift-A, under Mesh Primitives. And again, we can see that if we turn off the modifier, our plane is still there, just as it was before with no subdivisions. If we apply our modifier, then the changes will become permanent and uneditable in the Nodes editor. We can also transform our mesh in other ways, such as scaling it, rotating it, or moving its location. Let's add a transform geometry node. We can adjust the location here with the values for translation. We can also adjust the rotation here. And finally, we can adjust the scale down here. We can change these for any or all of the axes, and we can also keyframe these values to create an animation. Let's rotate this on the Z-axis. We'll start on frame 0 and keyframe 0 for the rotation, using our I key. Now we'll go to the end of our timeline and keyframe the value to 360. And we can see that our object spins when we play the animation. Let's take a quick look at a Boolean operator, and we'll place that right between our sphere and the transform geometry node. We'll leave this as difference, but note that intersect and union are also available. Now we'll add a cube for our other mesh object. We can scale our cube to see the effect. Let's add a transform geometry to move our cube over and see how that affects our mesh. Now let's disable this plane, and we're going to take a look at attributes and some of the things they can do. We'll discuss some of the built-in attributes like position, normal, and index. We'll also look at custom attributes and how they can be used. The position attribute contains the current position for each point in the geometry and determines its location in the 3D space using X, Y, Z coordinates. Let's add a new plane with a new geometry nodes modifier. Let's bring in our shape object to replace the current geometry. Now we'll add a set position node so we can adjust the placement of the vertices. Let's go ahead and add a position node and use a vector multiply. Then plug it into our offset. We can slide our multiplier up and down to affect the size of our object. When we have a zero offset though, it is the same as having these nodes not connected at all. We can also see that the positions in our spreadsheet change as well. Now let's take a look at the normal attribute. The normals represent a direction rather than a point in space. Normals are the direction perpendicular to the surface of the geometry. So let's add a normal node and then add a noise texture. We'll plug both of these into our multiply node. This will distort the position of each of our vertices in the direction of the normal. Let's check our spreadsheet with just the noise texture. Then plug the normal value back in and check our values once more. If we want to scale our displacement further, we can add another multiply math node. Now we can scale our multiplier up and down, and we can see the displacement get larger and smaller. The next attribute node we are going to discuss is the index node. You can see the index in the spreadsheet over here. It's the first column before we see the position. Let's create a new GeoNodes modifier. We're going to add back our subdivision mesh node and set the level to 4 again. We can see in the spreadsheet that our mesh now has 289 vertices. Let's add a delete geometry node. We'll leave this on point, but be aware that there are other options here. We also have the option to delete geometry by faces or edges. Now let's add an equal node from the Utilities, Math, Compare, and then plug our index into that. Now let's change our equal to a less than node. Now we can see that multiple faces are removed. And we can slide this comparison value up and down to control how much of our mesh is removed. Now let's add a Boolean math node to add an AND condition. We'll duplicate our less than node and set it to be a greater than node. We'll plug our index into the greater than node and plug the greater than into the second socket in our AND node. Let's go ahead and switch our delete geometry node to faces. Initially, we see that nothing is deleted. This is because nothing is both greater than and less than our number. So let's move the greater than value down, and now we can see that a range of geometry is removed. If we want to remove values from both the start and end of our index range, we can switch our AND to be an OR, and then increase the value on our greater than node. Now we can also increase the number for our less than value to adjust the range of faces that are remaining. As we saw earlier, one other thing we can do with our delete geometry is use a random value to control the selection. We can adjust how many faces are affected with the probability value here. And if we want to adjust the specific faces that are affected, we can adjust the seed value here. There are other attributes available, such as radius and color, among many others, that we're not going to look at today. And there are also custom attributes, where you can store and manipulate data specific to your needs. Let's take a look at an example. We're going to delete our current setup add a grid, and then set up an instance on points node. We'll talk more about instances and points later in this tutorial. Let's plug a cube into the instance socket and adjust the scale. And let's randomize our selection of points by hooking a random value node into the selection connector. We want to store the index of our instances, so we can assign a random color to each cube in our shader editor. Let's add the index node here and make some room for the other nodes we will need. First, we need to realize our instances, which will allow us to affect each instance separately. So we'll add a Realize Instances node here. Then we can add a Store Named Attribute node here after we realize our instances, and we can give this attribute any name. Since it's going to drive our color, I will name mine Color. Next, we'll connect our index node to the value socket. We can see in the spreadsheet that values now appear for the color attribute, and they are essentially integers starting at 0 and incrementing. Now let's see how we can use this value over in the shader editor. First, let's create a new material. Next, we're going to add a color ramp and add some colors to it. We want to change the color interpolation to constant so that we get distinct values rather than a mix of our colors. These are the colors that we will randomly assign to our cubes. Next, we want to add a white noise texture just before the color ramp. This will return a random number between 0 and 1 based on the input. Just before that, we want to add a math node set to snap. This will round the input value down to the nearest integer using multiples of the increment. Our cubes have 8 vertices, so we want to set the increment value to 8. This will give us a distinct value for each group of vertices that make up one of our cubed instances. Then we're going to bring in an attribute node and set this to the named color attribute we created in our geonodes. Recall that this is our index value. Let's name our material to random color. Now we can go back to our geonodes and assign a material. The only way to add a material to a generated mesh in geometry nodes is through the Set Material node. So we'll add that here, and we'll set that to our new material, Random Color. And we can see that our random materials appear over here. This is just one example, but it's good to know that we can capture and utilize values in this way. In part 2, we'll dive a bit deeper into instances and points and check out some of the cool things we can do with them. I'll see you there.